So for the next question, we're going to do yet another question from the atomic structure paper. We have the graph of the first ionization energy plotted against atomic number for the first 20 elements shows periodicity. So we can see here the first ionization energy and then across with the atomic number ranging from 1 to 20. And the first question, or the first part of the question that we have, is define the term first ionization energy. So first ionization energy is often portrayed if we had Mg, then breaks down into Mg plus an electron lost. And so what you have to state, even though it's 1 marks, there are 3 main things you have to state. It is the energy absorbed when 1 mole of electrons is lost, as we can see here, the electrons is lost, from 1 mole of atoms, here, Mg, to form 1 mole of positive ions, Mg+. And so from this, you can clearly demonstrate it this way, but in terms of words, this is how you would word it. And all of this occurs in gaseous state. So for all of them, there would be a little g, and obviously an electron is a gas. Anyway, so you don't necessarily have to write gas for that. But that is what you would need for all 1 mark. But you need all those 3 things to make sure you get the mark. Then for part 2, it says, explain how information from this graph provides evidence for the existence of main energy levels and sublevels within atoms. And this is 4 marks. So when we look back at the actual graph, we can see that there's a general increase across as you would go across the periodic table. So when you get to 10, that's the first, well, technically the second row that you have on the periodic table. And you can see that as soon as it's at 10, which is the peak, it then drops back down. So we can state that there's a general increase across the period and that the highest values are for noble gases. So obviously number 10, the element with the atomic number of 10 is neon, which is a noble gas. And then the lowest one is alkali metals. So straight after number 10, if we look back, you have 11. And 11 would be sodium on the periodic table. So you can see that the noble gas is then dropped down to an alkali metal, and the highest was in fact the noble gas, and that is because it's the most stable out of all the elements, and that the alkali metals is one of the easiest to remove electrons from. You could also state, so that is for the existence of main energy levels, and then these 2 are for the sublevels. And you can state that there's a drop in ionization energy from beryllium to boron, and that there's a drop in ionization energy from nitrogen to oxygen. So you have 2 examples for that, and that is because they are the 2 that you can use, because can't even say the word, Be is 4 and boron is 5, and nitrogen is 7 and oxygen is 8. And so what that means, if we look at for the example of nitrogen and oxygen, you can see that nitrogen, when it is drawn out in the electron diagrams, you can see that 1s2 is filled with 2 electrons, 2s is filled with 2 electrons too, and 2p only has 3 out of a potential 6 electrons. But when you look at oxygen, oxygen then fills up 2p, but there's 1 in 1 box. So this shows that the energy, there would be a difference in the energy between the 2, and there's a drop in ionization energy between nitrogen and oxygen, and that is because if you had to remove an electron, it would be easier to remove it from oxygen because there is now this spin pair repulsion between these 2 pairs of electrons, and thus it would be easier to remove it. And so that proves that there is the existence of these sublevels, because you can see even though they're within the same orbital and they're still within the same electron shell, it's still, you know, on the second one, but you can see that there is a difference because of the 2p is now being filled up a little more than it is in N. Finally, the last question on this part is state what is meant by the term second ionization energy. So this is quite similar to the first ionization energy that we already looked at. However, in this case, again, it's only 1 mark. In this case, instead of starting with Mg, you start with Mg plus, and it breaks down into Mg2 plus and an electron. Obviously, this is all again in gaseous state. So again, the marks included are energy absorbed when 1 mole of positive ions loses 1 mole of electrons to form 1 mole of 2 plus ions. And this again is all in gaseous state. So you could have written it out like this and still gotten the marks, or you could have written it all like this. It didn't really matter which one you decided to do. But yes, for all those 6 marks, those are what you had to include to ensure that you got all of them.